Good afternoon, everybody. So I probably say this every year, but I'll just say it again. And now for something completely different. We've been working on a website to visualize human genomics analysis results, mostly association study results. So in the first, actually I'm going to be doing a demo of where the tool stands right now, so I'm going to do the acknowledgments now. So obviously funded by our Facebase grant. Myself, Eleanor Feingold, Harry Hockheiser, and Elizabeth Leslie are the faculty sort of spearheading this. We've had a number of staff and students working on the project over the past few years. And a big shout out to Nandita and Myung-Kun who prepared the databases. And then other people for our database management and hardware and software management. So faculty on the side and the staff to the right. Which button is the pointer? Thin green line. I should be able to figure this out. Oh wait, maybe it's that. Oh, okay. Oh, that has the thin green line. Okay, that's why you were confusing me. Okay, so first, these are the goals that we had in our original submission and continue to be the goals. This is to develop a software interface for human genomics results. And we wanted this to be something that would be convenient for people in the research community who wanted to see what kinds of data, what kind of results are out there from our human genomics studies. So we wanted this interface to not require access to any individual level data. You know, so the things that I'm going to show you, the databases that we have up here, are all available at the individual level in places like dbGaP. However, there's a lot of barriers to getting data downloaded from dbGaP if you're not a human geneticist. You know, you have to have a certain degree of, computer support, security, and the ability to know just what, to know what you want. And having both the ability to get that data and the hardware and staff necessary to actually analyze it yourself is a barrier to a lot of people. If all you want to do is do a quick lookup of the results for a gene that you're interested in, for example. So that was one of our goals. The second goal was to identify appropriate projects to visualize in this tool, and then create and display the results from genomics projects. And we wanted to do this in graphical displays that were familiar to a lot of people in the genetics and human genomics community. So the two most common things that are used are Manhattan plots and locus zoom plots. So that would form the basis of the early iterations of this tool. So again, we wanted it to be user-friendly, to save user time. So in order to do that, we decided to do pre-calculated results databases, basically p-values at variance, SNPs for the most part. So for our relevant subsets, we also needed to calculate results databases, so by ethnicity, by whether you want just genotype SNPs versus imputed SNPs, by specific phenotypes, for example, for oral facial clefting, you can do subsets of families where there's cleft lip only or cleft palate only, cleft lip with or without cleft palate, et cetera, and in some cases by environmental factors that were measured for the particular study. Some of the results databases were customized with input from the PIs. Some of the PIs wanted to just have certain published results visualized rather than their whole data set. So the initial versions of this tool had static Manhattan plots and static locus zoom plots. So Manhattan plots show the whole genome, and locus zoom plots show some subset of the genome, like by a specific SNP, gene, or other region that you're interested in. So we had that working well, had a lot of visits to our site, but then started getting requests from users. How come we can't zoom over the points and figure out what the SNPs are? And I'm really interested in this gene. How do I quickly find it when we're talking about these static Manhattan and locus zoom plots? So we had some customized tools in there to be able to do that, but not to the degree that some of our users were asking for. So our goal over the last several months has been to add interactive Manhattan and locus zoom plots. Again, leveraging methods that are already out there. So we try not to reinvent the wheel. So University of Michigan, about the time we were hoping to do this, released an interactive version of locus zoom. So we wanted to use that. And then there's a number of like R programs for interactive Manhattan plots, so we used one of those. So I'm now going to switch to doing a live demo, despite how that might be an issue. So I have a favor to ask. Please don't try to follow along. Don't try to log on while I'm going through the demo. Afterwards, log on, try to break it, let me know what happens. Mary, this didn't work, let me know what happens, but so that I can at least get through the demo. Don't try to log into it right now. And it is available through the Resources tab on the Facebase website or through the project page. Whoops, I probably misspelled something. So either the project page or the Resources tab on the front page of Facebase. Okay, so this is what the basic landing page looks like. So we have three major categories of types of databases that are visualized here: oral facial clefting, normal facial variation, and dental traits. I don't know if my arrow's getting over there. So for each of these, you can get to the specific projects in a number of ways. You can click on oral facial clefting and you'll get a list of the projects are there. There's a project button up here. So let's just go to one of the projects. So this was a GWAS of oral facial clefts and related phenotypes. For each of the studies, we have a project description, methods, descriptive statistics, this explore project data and publications. So under the project description, we give the dbGaP study accession number, so you can click and go immediately to it in dbGaP. If you use this tool and decide, you've got to have the individual level data. Talks about who the investigators were, the funding sources, and gives a brief summary, of the study. The Methods tab either gives links where you can find the detailed methods, maybe in a publication or whatever, but also includes some brief text. In this particular study, we had case and control data, and we also had trios for TDT type analyses. Descriptive statistics describes the data set in a little more detail, like I think you can see it. So the proband clefting status, so like every cleft lip and palate data set, there's more people with cleft lip plus cleft palate, fewer people with cleft lip alone and cleft palate alone. We have it also broken down by ethnicity. For this study, we had Asians, Latinos, Europeans, and others. Okay, so it gives you an idea of the data that went into the analyses. Then in the Explore Project Data tab, this is what really changed in this latest version, allowing the user to do interactive Manhattan plots and interactive locus zoom plots. So let's start out with the combined ancestry groups. Let's start out with cleft palate. You can look at just the TDT or the trio results, just the case control results, which are non-overlapping data sets, or meta-analysis of both groups. Let's look at the meta-analysis. And if we look at the static Manhattan plot, this is what we originally had right here, the static Manhattan plot. You can download this if you want to save this. But then in this new version, we added an interactive Manhattan plot. So let's go look at this. So to orient you as you're using the interactive version, we bring the static plot up first at the top of this page. And yes, it takes a little time. This database is a very large one. So one of our goals for the coming year is to optimize this whole new version so that it moves a little faster. So it shows you this static Manhattan plot for cleft palate alone. And then for the interactive plot, because there are so many points in here, that we used just the chromosome by chromosome version of the interactive Manhattan plot. Chromosome 9 looks pretty interesting, so let's just go look at that. Yeah. And then this takes a little while. So this is, again, the things that we're hoping to address a little more in the coming year to make it a little more optimized for the large amount of data that we're talking about. And a little bit of sort of be a little patient text over here. And hopefully very soon this will come up. I should have gone to Locusum first, it's a lot faster. So this is the Manhattan plot for chromosome 9. And as you zoom through, you can see that it tells you, the best SNP name for the top of this peak, the one for that one, et cetera. You can zoom out or zoom in. You can take a particular part of it, like if you just want to pull out a particular peak, you can do that and look at it in more detail. And again, you can download the image that you've been working with. Okay, so let's stay with our selections and go to the interactive locusome. So this is located at the University of Michigan, the actual program, but we have our data formatted in such a way that it will directly come up in their process. So there's a lot on here, but it just brings up a particular landing spot, nothing in particular about that. But for a common use case, someone might say, I just saw Yang Chai talk about expression studies in his mouse work, and Wnt5a was an interesting gene. So what does it show in our cleft palate families? So you just enter the gene name, and if you did a typo, nothing will show up down here, but if you spelled it right, it'll come up. So unfortunately, Wnt5a doesn't look so great in this particular set of cleft palate families. But what you can also do, and this is something that a lot of people had also asked for, what about the other OFC data sets that you have on the tool? Can they be looked at simultaneously? So this interactive locusome does allow you to do that. So let's just add a study. So the studies you can add are ones that are located that have been uploaded at the University of Michigan. So our studies that we uploaded all have FB for Facebase. So we have 107 data sets, basically, that are available for looking at. The OFC studies have OFC, and you can see we have 40 data sets with various OFC data. So I happen to be working with OFC4, which is our multi-ethnic study, but we also have this OFC1. Let's look for cleft palate. Maybe on the next page. Let's just do OFC1. So here's cleft palate, and you can add it. It'll come up right underneath. And again, there's not really much of a hint of an association signal for Wnt5a in either of these data sets. But if you switch to a different gene, say IRF6, one of our favorites in cleft lip, and you'll see that there's not really much of a signal for IRF6 in the cleft palate alone families, but it simultaneously changes the image in both data sets. You can zoom out, you can zoom in, you can download your image, and you can look at more information about each of the genes, comes up down below. If you hover over these points, it tells you the location, the alleles at that location, and the specific p-value for the reference allele. It's interesting, they don't give you the RS number, so there's a little bit of additional work you have to do if you want to look up a specific RS number within LocusZoom. But if you have a specific RS number, you can readily look up its location, for example, in the browser or even in that interactive Manhattan plot. Okay, so let's get out of here. And so just, I guess, in the interest of time, I'll just kind of show you the very last tab is simply publication, PubMed list. We search on the grant number that created the GWAS, and there's been that many publications. Okay, so in the coming year, we'll be working on optimizing the website so that it's a little faster for these large data sets that we have. Each of the data sets have 6 to 10 million SNPs, and we have lots of different combinations of the phenotypes and ethnicities and so on. We have a few more data sets that were queued up to add, but we set those aside while we were trying to get these interactive versions working. We'll be working with the hub on moving the site to the hub over this final year, including working with them on how best to do that, and also to document how to add new data if that becomes something that NIDCR would like to see happen. Okay, thanks. Happy to answer any questions.
Any questions? No? Okay,
we'll stay
thank
on
you,
time.
Mary.
Thanks, guys.